Okay, everyone, good afternoon. Welcome to the presentation. Oh, I am your sole presenter, Colin Maloney. I've been drawing, measuring, scanning, and drafting and modeling as-built for decades now, and I've worked with precision property measurements for 13 years, doing these things in Los Angeles, the San Francisco Bay Area, and now here in Washington State. I currently reside in Seattle, and I'm really looking forward to getting to know more of you in the AIA Southwest Washington region, Tacoma, Olympia, and so on. AIA Southwest Washington is the continuing education provider for this program. I want to remind you to put your number in the chat, your AIA number, so that we can make sure that you get all the credit. And I'm just going to pause here so you can take a look at the official description and our learning objectives for the day. And while I do that, I'm going to see if I can get a way to look at your chat. Okay, there we go. Okay, maybe I don't need it that big. So yeah, please put all of your AIA numbers in the chat in order to receive credit. Here's the major sections we'll be covering in the presentation. We're going to talk about what as-built plans even are. We're going to talk about how we get the information for them on site, and then we'll talk about creating the actual as-built set of plans themselves. All right. So what are as-built plans? Whenever covering as-builts, the first thing you got to clarify is what exactly they are. I'm sure you've all heard them called different things like record drawings or existing conditions. Some might just say plans or blueprints when they're talking about as-builts. Record drawings are plans created after construction solely for the sake of having accurate, up-to-date information on record. This is great in theory for every municipality's archives to have, but it's rarely a reality. So for the purpose of this presentation, we'll be talking about as-builts in the sense of what is actually needed by architects like yourselves at the onset of a project. Accurate plans of all types, preferably in your native software, that you can use as a base for your new design, construction, and permitting documents. As I mentioned, as-builts can take many forms, but the one that's likely most useful for you in your practice comes in the software used by you and your team. There are some common 3D programs on the screen used to create models, as well as the tried and true 2D method of using AutoCAD. To get to this point, lots of information needs to be gathered, and there are multiple ways to go about it. You can research the city's plan archives, or crawl up into the homeowner's attic to look for plans, or go into the engineering office at your buildings project for old documents that you can try to make sense out of. You can go out and take measurements in any number of ways on site, take photos, use a LiDAR scanner. The way that you go about this will likely determine the ease of translating it into one of the formats above and the overall accuracy of your plans as well. I just want to also mention right now that we're going to do Q&A at the end. So please just, if you can, save any questions that you have until the end. But we will be doing polls as well. So I'll interrupt the presentation for a brief poll. Everyone chime in just by writing your answers in the chat for this. How do you currently generate your as-built plans? And you can answer, I create them myself. We have a team at our company that does them, or you partner with another professional. So just let me know what your preference is, what your method is. Curious about that. Always curious to hear. And just keep answering, that's fine. and we'll go into collecting the data on site. So now that we understand what we're talking about with as-builts, let's talk about some of the various ways to collect the info on site to be used to create our as-built set of plans. In discussing on-site methods, we're going to divide the discussion into two main parts, okay? Traditional and advanced. Traditional will be all the methods used besides scanning, and advanced will mean scanning. Advanced, in most cases, will still require a good understanding and sometimes implementation of the traditional methods to achieve the results needed. So to start, here's the subject that's near and dear to my heart, traditional methods of on-site as-built documentation. In the photo here, you see the president of my company posing in a way that you might sketch. So remember that sketching doesn't need to be to scale. All you need to do is make sure that there's room to write all the measurements you need and that it's visually easy to follow back in the office. Using different colors to mark different measurements and drawing types is helpful so that your eye will catch each segment accordingly when you're drafting. And you don't spend as much time hunting on that sheet of paper for what you need. Getting as much sketching done as you can before measuring is recommended so that you can just focus on measurement when the time comes and execute. The better your sketching is, the easier your measurements will be. If sketched correctly, any structure can be measured quickly. You want to plan ahead and get your heights or measurements on the z-axis. Most of the time, this information can be displayed in plan view, but occasionally you'll want to sketch in section or elevation view. We'll talk about this again in the next few slides. You also want to sketch out any details or ornamentation to the degree of precision you desire as well. An important step that people might skip when measuring a structure is going around the exterior faces. Often a wall thickness is taken at an exterior door and then the interior measurements only from there. I consider this step to be crucial. So you start with the perimeter faces, measure all the lengths 360 degrees around the structure, and then you take the sum of the X values on one side, say the left side, add them up, and then you add up the X values on the right side. And if they're the same number or very close, then you're on the right track. And you want to do that with the same thing, the Y values. This will encapsulate that. So it can get complicated if your structure has curved walls or angles that aren't 90 degrees, of course. Then you might have to bust out some of your old geometry skills. In this sketch, you'll notice that there's some overall measurements as well as small incremental measurements. This is a good system of checks and balances that will not only improve overall accuracy, it may save you in the event that you have an incorrect measurement or notation. Don't forget to get good photo coverage as well. This will help you to verify that what you're drafting is indeed correct. Occasionally, I've seen errors that don't appear as errors on paper, but they're obvious when you're looking at an image. And if anybody's just now joining, I'll repeat, put your AIA number in the chat so that you can get credits for this. Just wanted to throw that out there. Here's an example of utilizing vellum to add even more measurements within an already sketched plan. You can borrow from what you sketched beneath. You won't have to redraw the walls, for example, and you can quickly throw in symbols and their measurements. Now let's chat briefly about getting those measurements in the third dimension, or the z-axis. You can use a tape measure. Ooh, we got a little effect there. To measure all the risers and the stairs. You can drop it down a balcony. You can run them up a wall. A laser distance meter, or disto, can perform trigonomic functions instantly and get you heights in all sorts of ways on your project. And the first two of these tools you might already be using to measure other aspects of your plans, but the third is used exclusively to measure heights. It's called the zip level. It's an excellent tool invented, distributed, and repaired if needed by a company out of San Diego. I'm not aware of any other version of this tool. It uses displacement to read heights anywhere within a 50-foot radius. I think you might be able to get it with a 100-foot cable too. However you've collected your height measurements, make sure you've got them in the places that you'll need them. Most of the areas will be obvious, like the tops of any stairs or steps. The drawings that you're seeing, I just want to have a note about, they can be simple. It doesn't have to go into the Museum of Art. Just document what you'll need to see when you're creating those plans later and let the numbers do the talking. Plan on what you'll need to see in those exterior elevations and sections. Make sure that you either have some height and good pitch information for your roof, or every height if you can get on the roof and it's safe to climb around up there. Make sure you don't forget the heights of openings such as windows in areas you plan to show, or the heights of things like a sconce on the wall if you're planning to produce detailed interior elevations. Now that we've scratched the surface of what goes into getting your as-built via those traditional methods, we'll now get into the new methods using some advanced technology. Updating or replacing a proven method for doing something to utilize the newest technology isn't easy, no matter what industry you're in. Even though it may be difficult to transition, making the change to laser scanning as a survey method provides you with fast data, more accurate measurements. You can purchase it, rent it, or contract it out. It allows you to gather more data than you need in the field, and it provides that digital twin if the project ever needs to be revisited or additions need to be made to your scope of work. The type of scanning we're doing involves LiDAR, light detection and ranging. LiDAR is a method for measuring distances by illuminating an object with a laser and measuring that laser beam's reflection with a sensor. Each one of these illuminations can be considered an individual measurement. Each single measurement is logged in a list, and throughout the scan, and millions of measurements are taken in all directions. When we need very accurate measurements or a lot of intricate detail captured for historical projects, or we need to cover acres of square footage, we will use a terrestrial scanner, which is a mounted scanner that takes one scan at a time in a fixed position. At PPM, our favorite terrestrial scanner is the Leica RTC 360. And there it is, scanning the Casa del Mar Hotel in Los Angeles, I believe. Even though this needs to be set up on a tripod, the individual scan times for the RTC 360 are relatively short compared to other terrestrial scanners, making it the fastest terrestrial option out there. The iPad app also helps make sure you can check your point clouds before leaving the job site. The RTC 360 is extremely precise and gathers so much data that the point cloud files can be over 500 gigabytes easily. Whether you use the onboard camera to make a color point cloud or not, you always get very dense, very accurate data that allows us to draft and model ornamentation detail, pipes and conduit, and other intricate details with precision. Because our final data is made up of hundreds or even thousands of scans performed with this scanner, it makes it ideal for the starting and stopping sometimes required in busy spaces like hotels, shopping centers, industrial spaces. In the next slide, we'll see a short video of a scan taken with this scanner. There we go. While our other scanners can be moved while they are operating, the RTC 360 needs to be placed in multiple positions all over the building to get a full set of measurements for our plans. Each red dot that you see here is a place where we strategically position the scanner to gather the black and white data you see here. Even though we did not use the camera for this data, you can see how much detail we get in using the black and white measurements gathered. Each black and white point or pixel is a representation of an actual laser measurement accurate down to less than 2 millimeters. This means that the entire 3D picture you're looking at is dimensionally accurate. We use this data to help an architect identify floor sagging, walls that are out of plumb, and other structural issues before a major remodel of this, which was a 100-year-old casino in Colorado. Just to give you an idea of the site times for some of these projects, here's a couple of examples. First is a local project we finished in early 2022, the Olympia Hotel at Capitol Lake. Check out this video. It not only shows the point cloud data, but our Revit model being built from the ground up. I believe that was 178,000 square feet. It took us 176 hours to model. The Marin Veterans Auditorium in Marin County, a building designed by Frank Lloyd Wright, is a perfect and recent example of what we can do with this kind of hyper-accurate data. Our surveyor used the RTC 360 and spent 74 hours over 7 days at this site, scanned every single room and interstitial space, including subfloors and above ceiling lofts of the 55,000 square foot auditorium. It took our modeling team a combined total of 304 hours to model every single architectural, structural, and almost every mechanical feature in the building. The client wanted literally everything on that one. Okay, so when time on site is a factor and the degree of precision and detail doesn't need to be quite as high, mobile LiDAR scanners can be used. Mobile LiDAR scanners are handheld and quite easy to use. Since most individual scans can take only 15 to 45 minutes, we recommend that you process the scan on site to check your results before you leave the site. Once the scan is complete, you need to use the SLAM algorithm software, which interprets all those measurements and movement data from the scanner to produce a singular 3D point cloud. After the 3D point cloud has been created, you need to review the cloud to ensure accuracy. Most errors that occurred when scanning can be spotted quickly, and you will see in the coming slides a few examples of that. Actions such as rescanning can be taken to ensure the overall accuracy of the project. This is what point cloud data looks like in plan view. You can also see that even though there's no photo-based colorization of the points are colored on something called a height ramp, where points at different heights are shown at different colors on a spectrum, which you can see on the left. Red is a lower height, blue is higher. Coloring the points this way makes it easier to see important features in the point cloud. One of the types of mobile scanner we've been using is called the Zeb Horizon. It is very powerful. It collects 300,000 points per second while you're walking and scanning. You can pretty much use this to scan anything. It's built like a tank. It will give you reliable output with the exception of the occasional error. Here's an example of a project we scan using the Horizon mobile scanner. It's a 9,000 square foot single family residence in Washington, D.C. This beautiful property was built in 1836, and as you can imagine, there were no as-built plans for the owners to reference. The project was modeled in ArchiCAD, and it took about 36 hours to create from the point cloud data. Total time spent on site surveying was unbelievably 6 hours. Just imagine how long it would be if you were doing this with your sketchboard. This is a photo of not only a wonderful person named Frank Guerrero, but the Zeb Revo scanner. It's slightly smaller than the Horizon. It's one of the first LiDAR scanners I ever was trained to use, and it definitely had an impact on my opinion of those traditional measurement methods I used to hold so dear. All right, so now that we've explored the tools used for the advanced method of data collection, let's take a quick look at the point cloud those tools produce. So reviewing your data well before attempting to create the plans is a must. If there are any kinds of errors with your cloud, which do happen, you want to make sure you catch those before you start drafting. So once it's processed, you want to make sure, did you cover all the areas? Are there any flaws or errors? Is there any drifting? And you want to address those issues. So you want to make sure to look for drifting, which can occur when the software has trouble putting those points together. If this occurs, you can try some reprocessing options or simply scan the structure again. You might have better luck the next time. Drifting includes reflection noise, data noise, internal scanner errors, mirrors that are reflecting data on site, and just duplicate data. It's important to keep an eye out for multiple types of drifting inside and outside of the building. You can see that exterior wall is very much askew, and that was not happening in the real world. Drifting is common with mobile scanners, and it occurs for several different reasons. So determining which reason is helpful for attempting to reprocess or rescan the project. Processing requires all areas having data connecting one area to the other so they can be properly glued together. Mirrors, moving objects can also trick the process and therefore give you bad output. The screenshot you see here is a multi-level structure and a space with few unique features. And additionally is an open, empty space, and it did actually pose a lot of challenges while on site. When you're also scanning attics, foundations, small cramped areas, or conversely very large sites, multi-level structures, they can pose those data integration challenges. Difficult to reach areas, reflective surfaces, and featureless spaces like office hallways or hotel room hallways can also be particularly problematic. Since the scanners have such a wide range, you want to trim or crop the point clouds to eliminate excess data from the long-range scanners. For large projects, utilize point cloud software to merge and streamline your data management. Much like the traditional method of sketching and measuring, properly scanning a structure takes lots of practice to do correctly and efficiently. Once you're practiced with scanning and know what to look for when errors have occurred, you will have the most reliable version of data you can gather in the field. You can be confident that the as-built plans you will create will be fully accurate and ensure a smooth and safe renovation as it progresses. And now that you've collected the data with your scanner and you're confident in the point cloud it's produced, it's time to create the actual plan sets. But first, let's do another poll. Please answer in the chat. What software do you work in? I realize that there are more options than what is presented on this list, but please just answer. And if you're in Chief Architect, if you're in Vectorworks, if you're in any number of other softwares, maybe just chime in with that. Or pick the closest one that you use if you need to do some sort of export. So I'll give you a minute to answer. Everybody answer with your preferred software.
Could you click to the next slide? It's still showing section 3. That way they can see the answers on the screen.
I'm sorry, Amber, I did not catch that. If that was you.
On the screen, it shows section 3, creating an as-built plan set.
Oh,
Click to the next slide so they can see the options.
you're right. There we go. There are your options for the poll. Oh. AutoCAD and SketchUp. Good. Okay, moving right along. We're going to touch briefly on the two different ways when producing as-built plans from a point cloud that you can go about it. Drafting in 2D and modeling in 3D. Let's start with drafting, and we can assume this is using standard AutoCAD. Or at least that's the language I'll be using. When drafting from a point cloud, the first thing you need to do is get into a drawing environment. This can be imported directly into AutoCAD or Revit, as well as other architectural software. If you use Autodesk products, you'll need to use an application called Recap to prepare the point cloud to ensure it works within their software suite. Drafting from a point cloud in CAD is pretty straightforward, but it takes some getting used to. There are lots of options in CAD to color, slice, crop, move, and rotate the cloud in different ways. And you'll need to use the view cube to regularly adjust your UCS orientation properly to work with the cloud in different positions. The tools for visualizing the point cloud are actually more robust in AutoCAD than just about any 3D software, which seems weird, but that's where we're at. Hopefully the 3D softwares will catch up to us, help us to view these point clouds, which are also 3D, a little better. In the image, here's an example of a slice of a point cloud in plan view. And you can see it looks like a floor plan. It's even got all the furniture in the house. When drafting in CAD from a point cloud, you want to ensure that your cloud is positioned orthogonally and that it's also good to position the cloud on that Z-axis as well. Once you have the point cloud well positioned to begin drafting, you should be able to derive all the walls, doors, door swings, and any other visible architectural and structural information right from the point cloud. Some items like windows can pose some difficulties when trying to get an exact width and height information, but with diligence and practice at manipulating the point cloud, it gets easier. Some scanners will not pick up smaller items, especially if they're flush with the walls or ceilings. So trying to locate that in the cloud can be very time consuming. In that case, it's often better to go back and revert to those traditional methods and just sketch and measure those items. When drafting other views, such as an elevation or cloud from the section, this is where a huge advantage to having a complete point cloud comes. Provided that you are able to access the roof in scanning, you will have a complete picture of not only the roof behavior, but also every height you'll need to properly draft your roof, exterior elevations, and sections. Just going to leave that graphic up there because it's pretty cool. I think that was a power plant in Oakland, if I'm not mistaken. Okay, so now that you've seen how we set up the point cloud in AutoCAD for drafting, let's also examine how this setup works in 3D. I might mention Revit automatically since that's 3D software I'm most accustomed to, but the majority of these principles are the same whether you're working in ArchiCAD, Revit, SketchUp, or you name it. When talking about any 3D model, it's good to apply the LOD system, the level of development system created for the AEC community to put standards on BIM drawings. It describes the different ways in which 3D objects can represent existing or design elements in a BIM model. With level 100 being the lowest, meaning you just mass your objects roughly, and 500 being the highest, being that they're so detailed and exact, you're essentially building a virtual version of the structure. When modeling as-builts, LOD 200 seems to be the most applicable range since you're accessing a structure that has been built from the outside, with many interstitial spaces being inaccessible and the specific construction of many architectural and structural elements that you can't see and cannot be determined. It's required for LOD 300 and above models. And usually those are created for things you're building from the ground up. Having three-dimensional data set when you're attempting to model in Revit is optimal, to say the least. I've tried myself to enter from those measured sketches or import 2D elements such as elevations to help me model, and it can get pretty dicey. Revit software is set up to manipulate your model along with the point cloud, viewing what you need from the angle that you need it. How far you choose to go with the model is really your choice, especially when you have such rich and complete data. As with setting up your point cloud in 2D drafting software, when modeling in Revit from a point cloud, you want to ensure that your cloud is positioned orthogonally in plan views, so that you can use the orgo function to place walls using the wall tool. You'll want to set that finished floor to your 0, 0 level, and then create all other levels to keep the key features aligned with the point cloud. Once you've done setting the finished floor, you can adjust. Oops, forgot to silence that thing. Once you've set the finished floor, you can adjust your view range and your view depths and your plan views to add your wall, door, and window families in the places indicated on the point cloud. There's some advantages to having a BIM model, which some people may not know. Sometimes a three-dimensional model is only considered for presentation and design purposes, but it also can be useful for an as-built as well. And I know there's lots of CEU courses that talk about that, building information modeling. You can view it in multiple phases. When you have a BIM model, you can move from design to construction documents pretty efficiently. Can be easier to understand that if you haven't visited the site yourself. You can cut those sections, use the camera tool, all sorts of things, and dig around in your 3D model. And some people just think it offers a more intuitive design experience and allows you to present 3D images and renderings at the planning stages to the owner or planning departments. Now it's time for our last poll of the day before our Q&A session. So please let us know, what's the most important factor to you when generating your as-built plans? Is it quality and accuracy? Is it the timeliness and overall turnaround time? Is it overall efficiency or the cost? Please put your answers in the chat. And then we'll go on to Q&A, and I finished in a shocking 35, 34 minutes. I hope I didn't sound like the Micro Machines guy. I like how that someone says that's a trick question. It is not. You have to prioritize. There's got to be something there. Okay. All right. Please answer. Take your time, but get it in there. And then I'm going to open it up to Q&A. So would anybody like to ask any questions? Go ahead and turn off your mic and just speak up.
I have a quick question. Now, this is Innocent with Ferguson Architecture. I just want to get your perspective, at least from your experience, and at what scale do you separate the point cloud kind of data sets, right? For example, if you're scanning like the one that you mentioned, I think it was 178,000 square feet. How many point cloud data sets did you have and merge in that?
Oh, that's a tough to answer because if we're using the terrestrial scanner, there's going to maybe even be as many as 1,000 specific points where we've taken a scan. The scanner has remained in place for maybe 1.5 minutes or so. Then we move it to the next position and register it. But I think the answer to that is just as many as it takes. And when you're in the field and you're using that iPad application, you can see if it's going to be functional, if you need more data. And that's why it's so important to be reviewing this information while you're on site and before you move on to the next thing. Great question.
Gotcha. And just a clarifying question, and that's particularly when you're using the terrestrial scanner, right?
Yes, if I were
Fantastic.
to use a mobile scanner,
Yep.
the goal is to scan everything in one scan. If you are using a mobile scanner on a very, very large project, then you will have to do multiple scans. And again, it's just about you're up against the clock when using a mobile scanner, especially one like the Horizon that I mentioned earlier. It takes such a massive amount of information that you really are limited to. You don't want to go over about 25 minutes scanning it because then your file will just simply be too big. You might run into an error. It may not even open. It may not work. So really it is about time and moving around the site. And then if you have multiple scans from a mobile scanner, then you need to register them together using any of several different methods to register those together.
Makes sense. Thanks.
Mm-hmm.
I have a question. When you guys are drafting your models, are these your staff or a contractor? And are they in the United States or are they outsourced?
I'm gonna have to, I think I need to get out of this sharing because I just can't hear and I need to make sure my volume's all the way up. Hang on a second. All right, I'm sorry. Could you ask that question again?
Yes. When you're modeling this, are they your staff that's modeling or are they a third-party contractor? And are your staff or their staff in the United States or are they outsourced?
Oh, great question. So the majority of our projects are modeled in-house by employees. We have an entire staff that we train from the ground up to do this. And that's the way it's done primarily. That's how we came up with our standard system. Every project undergoes quality assurance in-house at PPM as well and audits. But for flexibility, we do have contract talent that we've acquired over the years all over the country, primarily in the United States. I don't know of anyone outside of the United States that we work with. But yeah, that helps us flex in those times where, you know, it's a boom and we just can't handle the workload. We're at the mercy of the economy and all that stuff. So yeah. Does that answer your question?
Yes.
I have a question. And you might have talked about this already, but when you're going out and doing these scans, it basically just gives you a big massing, and then you have to go through and build the model in Revit or whatever program, identify materials, all that kind of information, or is there some other system where you can just take the scan and it will understand the materials, or what's a wall versus what's a window versus what's brick or whatever, and put that into a usable model?
Great question. I think that technology is working on it, what you're talking about, but I have not seen anything anywhere close to accurate that just produces plans automatically out of a point cloud. You still have to go in there and manually create the plans. The point cloud is the data set. It's your essentially your sketch. All your measurements are there. It's a perfect 3D representation of what you want to create plans for, but you still have to do the work of creating the plans. If you do use one of those more powerful terrestrial scanners and you get a colorized point cloud, that's about as close as you can get to what you're talking about, where you can visually see the materials pretty clearly. But if you want to translate that into workable, usable plans that you can edit, then you have to create them.
Colin, we have a question in the chat from David Brittle. He says, please describe LOD levels.
Okay, so I think that I'm gonna go ahead and blame the AIA. I think they're the ones who created the LOD system originally, but it was just when BIM models were becoming more and more popular and architects like yourselves were using them, they needed to wrap their heads around some sort of rating system for them. and it's LOD, you would think it's level of detail, but it's level of development. How far has someone gone to develop this model? I am not, I think we have the rating systems, but I've talked to many, many firms and individuals about this, and it's still a little bit subjective as far as what is what. Is this LOD 200 or is this LOD 300? And so on. I've actually worked with firms that have created their own documentation for it. They have like, a book this thick that explains, okay, here's what a foundation footing looks like in 200. Here's what it looks like in 300. Here's what it looks like in 400. And that they will set their own standards and give them to us when we're modeling. But to try to answer your question, 100 is the lowest, and it means that you're just using massing tools. So if you're in San Francisco and you have some row houses type deals, it's just going to be cubes at the heights that they are, and maybe you'll do a little bay window shape popping out of the front, and so on. So that's the lowest level possible. When you get into 200, that's more where we're modeling our models. So putting it in terms of Revit, we're using system families like walls, walls, ceilings, floors, but using the generic settings for those. So we're not going to show that the floor has, 6-inch joists at 16 on center within it, and there's a layer of plywood, and then there's this and that. And that's because you can't make those assumptions unless you take a chainsaw to the floor. So that's where LOD 200 kind of lands you, is a workable set of architectural plans. 300, you're getting into more of that ornamentation. You're showing base, case, and crown within the walls and things like that. And then 500 is the top level. It's the most possible detail you can put into a plan. And again, that's subjective. You might say that it's got all the topography of the site with all the landscaping and planting, and the house is just built with every single component that you can possibly use in the software that you're using.
I actually have a visual, Colin. I can maybe put it in the chat or to show you guys. It's not something that PM generated. It's a couple other BIM companies, but there's some visual examples you guys might find helpful.
Yeah, throw it in the chat. I don't know if you can take a hold of screen sharing, Amber. But anyone else in the meantime have another question?
Yeah, I actually have another one. For detail, like in Amber's background of like an older building that has all the, various detail levels of a column, a capital, those kind of things. If you're trying to do that like extremely high level detailed model, are you still going in and doing like a model in place or creating a family, or is there like another program that will go in there and kind of model that for you and you can just place it, or how would you do something like that?
Option one, you are going in there and modeling in place every little component for it. And that's something, we have to do. There's a lot of modeling in place that goes into our models so that they have the correct geometry. Fireplaces are a big one. We're always trying to model something like that as specifically as we can, but you have the point cloud right there in the model. So you're kind of in 2D, I like to call it, you're tracing on top of it. And then in 3D, you are modeling right on top of it. So it will let you know kind of the boundaries that you have, but you are actually doing that work. Great question. I hope I answered it.
I have another question.
Sure.
When you're modeling, let's say you model a commercial building, are you modeling generic walls where this is a 5.5-inch wall assembly and it's just a generic 5.5-inch wall? Or are you building families that say what the characteristics of that wall are? So are they coming up as wall types, or are they coming up as blank blank walls?
Traditionally, if I were working with the client and they were to give me some guidelines for that they want, or we're using their template, for example, we might go further, but our standard wall, whether it's commercial or residential, is going to be modeled to the correct thickness, but be generic. So it will not show the interstitial space when the wall or the components. Some clients, especially those that work in 2D, will have us add leaders just with like a material call out of some sort, which we can do. But we definitely don't like to make assumptions about wall construction and things like that without, we like to say whatever is visible and measurable is included in the plans. And that's just to make sure that we aren't relaying any incorrect information that way. All right, any other questions?
We have another one in the chat from David. What is the basic cost to LiDAR and model a 2,000 square foot basic house?
Oh, good question. Well, at PPM, our pricing is based on 3 factors. One is going to be the gross square footage, which you're giving me there. 2 is going to be the scope of work for the plans, and that's the biggest needle mover. So we always try to put it in terms of an architectural sheet set of plans. The most basic scope for a remodel is obviously just a floor plan. And if you're talking about that, it's pretty cheap on the low end. The third factor is the complexity of the structure. So I want to look and see, is it going up and down a hillside? Is the roof really complex? What architectural style is it? Does it have any non-rectilinear walls like curves or angles? So that's going to go into it, and I'll give it kind of a complexity rating. If you wanted a really basic number off the top of my head right now for a scope, like let's say you need floor plans, a roof plan, and exterior elevations, that's going to land somewhere below or above $1 a square foot if it's a pretty standard residential project. If it's really basic, single ridge, 1 story, it's probably going to be closer to 50 cents a foot. But it can go from there. We do very custom residential of a fancy big residence, and it'll approach $2-3 a foot, depending on what you want. And then of course, if you want us to show all the faceplates of the electrical and the switches and everything like that, then the price will increase from there.
A follow-up question on that, is your final deliverable a set of plans, 2D drawings, or is it a built-up 3D model, or is that dependent on what the client wants?
It's dependent on what the client wants. At Precision Property Measurements, we offer 2D AutoCAD, 3D Revit, 3D ArchiCAD, and 3D SketchUp currently. I think Vectorworks is our next on the list, but we haven't gotten into that yet. So you choose your final deliverable, and then the total deliverable package is a full set of still photos from the site, because we have to take those so that our drafters and modelers can know what they're looking at. Sometimes the point cloud can be kind of confusing. So you're going to get photos, you're going to get the deliverable software item that you choose, and that's the main asset. That's what you can take and edit and create new plans with. And then we create a PDF set. And the PDF set should look, depending on the scope that you chose, it should look identical, whether it's created from CAD, Revit, ArchiCAD, whatever. Those sheets, your floor plan sheets, your exterior elevations will look the same, in case you want to print right away.
Yeah, thank you.
Any other questions? Going once, going twice. Okay, I'm going to put up one more slide. Oh, oops. Hang on just a second here. I want to share. thank you all again for attending. We hope you were able to gain some insight and perhaps get the chance to collaborate with some of you in the future. I will. And lastly, our marketing team will be in touch with our raffle winner. Believe it or not, you were entered into a raffle. You might win some awesome Legos. I have several in the office here. I just completed London and Chicago. So my information's there. You're welcome to give me a call or shoot me an email anytime.
Colin, can you share your screen? We don't see it, so I want to make sure they see your contact
Is that
info.
right? Okay. Thank you. Thank you. I thought I was sharing my screen. Oh, I gotta hit share. Okay, there we go. There we are. Can you see that?
Yep.
Yes. Okay.
Yes, same.
Here I was talking about Legos, and you guys had no idea what I was talking about. There they are. There's my information. Please jot it down if you have any questions. If you're stuck on site trying to sketch your own as-builts, I'll be happy to help you. I really do enjoy that stuff. And yeah, thank you so much, AIA, Southwest Washington. I really look forward to getting to know more of you and going to AIA functions this year. Reach out to me for any of that stuff. If you guys have a happy hour that you're getting together for, I'd love to attend it. And have a great weekend. Thank you.